Last time on Building Resilience, we were cutting styrofoam, gluing the back, and sticking it to the walls in 2 crawl spaces where we had already plopped it on the floor. That's when we broke out the froth pack.
All right, spray foam insulation. It's a big part of how we build today. It's one of the key ingredients in our building type. And DuPont happens to make something called froth pack, which is kind of a more portable version if you don't need to necessarily foam an entire house. You got some smaller areas that you need to address. Comes in a red version and a green version in a variety of different sizes. What you need to know is green is for air sealing and red is fire rated. And I don't care how much you think you know about spray foam, always stop and read the instructions before you use any chemical product like this. It's not hard to use, but it's really important that you use it properly, safely, and it's got some very specific steps that it walks you through before you use it.
This week, we're going to dig a little deeper into the mechanical systems that provide heating and cooling to each part of the house.
So, heating and cooling systems. This house has a boiler, which means that we've got radiators throughout the house that are providing really great heat. We've got in-floor, we've got standard cast iron all over. But cooling is something that these old houses didn't come with. Now, upstairs in the attic, where we, foamed the whole lid and made this thing super, super, super tight, we were able to put an air handler in what we might think of as a traditional forced air cooling system that's providing cooling to the second floor. Very short duct runs, easy to do, easy to balance. And because our BTU load overall went down, we're able to put a fairly small air handler from Mitsubishi up there. Now, when it comes to the first floor, we don't really have a great way to bring enough ductwork down to the first floor to provide cooling. And moreover, I don't particularly like ductwork. It usually gets pretty gross in there. People don't clean it as often as they should. And so the other way to bring cooling into a house is with mini splits. But when you say mini splits, oftentimes people's first reaction is kind of like, ugh. They don't like the wall wart, they don't like the thing that sits on the wall. And Mitsubishi came up with a really, really brilliant system for us to bring mini split cooling into a space without having the thing on the wall that people object to. It's actually right above me. In the ceiling, we have a ceiling cassette. Now this is a traditional mini split in the way that we would normally think of it. Except that the only thing we're going to see is a white grill on the ceiling, like a ceiling fan or something else. Other benefit of putting it here in the kitchen is I've got some south facing and I've got some west facing glass, so this is going to be a really warm space. And in terms of comfort, how the person reacts to the space, this is going to provide cooling where they need it and want it most.
Mini split air source heat pumps can provide heating or cooling right where it's needed, rather than where it's needed and everywhere else in the house. In the kitchen, a ceiling-mounted unit provides cooling, and in the renovated basement, another one provides heating and cooling. The hyperheat technology of Mitsubishi mini splits means they work well in very cold climates like Minneapolis. Both of the mini splits can be controlled from your phone with an app or with a remote control contraption that is much harder to lose. An air handler in the attic provides cool air to the upstairs of the house. 100 years ago, when the house was built, very little insulation was used. Even when they did begin insulating attics, it was usually in the attic floor and it was usually inadequate. Air conditioning equipment that was added in the 80s and 90s was added above this insulation, putting the AC unit outside the house. To tighten the shell and place the mechanical equipment inside the thermal envelope of the house, we're going to use spray foam on the underside of the roof deck. The attic is the hottest part of the house during summer, so it's critical to get that air handler out of the heat and into the house. Downstairs, the Mitsubishi units are great for remodeling because they slip between 16-inch on-center framing, which happens to be the way this house was built. The cover plate is left off until the drywall goes up, so the guts of the unit are protected with a temporary cover. Refrigerant and condensate lines from inside the unit can snake through the framing of the ceilings, walls, and floors on their way to the outside compressor unit where excess warm or cool air is dumped. As long as we're out here looking at mechanical stuff, let's look at the white PVC pipe running up the side of the house. That's a radon mitigation system sucking soil gases from under the basement slab up, out, and away. Okay, we're gonna jump into the Wayback Machine and look at the before scenario for this attic. We climbed up there in late June, and it was warm.
Yeah, it's warm up here. This is nice. We got our refrigerant line just dangling here. Looks like someone tried to use duct tape to hold it together. And we've got, got our air handler up in here in this hot attic. Insulation on the floor is kind of iffy. Some mouse droppings and whatnot. We're gonna change this whole condition. We're gonna put R50 on the roof line. We're gonna bring all the ductwork and the mechanicals inside the conditioned space. Get a new air handler up here. That'll be tied to a condenser that's also running a couple of our mini splits below. And ultimately, this fairly awkward, hot, uncomfortable space is gonna become super comfortable, and the house's overall efficiency is gonna jump pretty dramatically.
Another tricky space in this house is the sunroom. It should stay warm in the winter with this classic radiator fed by a high-efficiency boiler and triple-pane windows, but even with a low solar heat gain coefficient, this room is likely to need cooling in order to live up to its full potential. So we're going to put one of Mitsubishi's Easy Fit ceiling cassettes into the ceiling, running the condensate and refrigerated lines down the wall, across the floor system, and out the house to the condenser unit. And speaking of getting out of the house, a big piece of IAQ is GTFO, or getting pollutants out of the living space. One of the existing pollutants in need of a GTFO IAQ improvement is carbon monoxide, which comes from atmospherically vented combustion appliances, like this water heater.
We're gonna talk about mechanical equipment a little bit. It's at the heart of the home. It's providing the heat for the house, the hot water for the house. And this in and of itself, is a finely made piece of equipment, except for one major problem, and that is it's atmospherically venting. And yes, technically they're legal, but they probably shouldn't be. What we want to do is make sure that any appliance that we have like this that is burning flue gas isn't relying on an atmospherically venting method of exhausting that gas from the house. So we were going to talk about sealed combustion, so it's not using occupant air for the fuel, and direct vent for our appliances. So the air that these things use, we want it to be separate from the air that these things use.
And that's not just a bunch of hot air. IAQ is a BFD in tight houses, and mechanical systems can work much more efficiently and as intended when they're part of a finely designed system. And speaking of a finely designed system, next week we're going to peek into the water and air control systems on these exterior walls. We'll install a new peel and stick weather-resistant barrier from Benjamin Opdyke and a tried and true invisible WRB to back up the open cladding system from AZEK. All of that comes next time on Building Resilience.